everyone. We have a Nemo problem. Let's solve it. We have x squared here minus 1 plus y squared by x minus 1 equals 1 xy integers. This equation can be transformed like this. And like this, xy minus 2x plus 1, and then we put a equals x plus y and b equals xy. So our equation is transformed into the following: ab equals a squared minus minus 2b plus 1. So we have a quadratic equation on A, which can be written like this: minus AB minus 2B minus 1 equals 0. The unknown is A. So we use the discriminant delta square equals b square plus 4 multiplied by 2b minus 1 equals b square plus 8b minus 4, which is equal to b plus 4 square minus 20. For our equation to be to have an integer solution, we need delta to be an integer, delta positive integer. So we have b plus 4 squared minus delta square equals 20, and this implies b plus I will use c instead of delta. B plus 4 minus c multiplied by b plus 4 plus c equals 20. 20 is 2 square minus multiplied by 5. So b plus 4 minus c and b plus 4 plus c have the same parity. To be convinced, just sum these two quantities, for example, and if you sum these two quantities, you get 2 multiplied by b plus c, and the presence of these two tells you that these quantities have the same parity. And because the right hand side is even, thus the two quantities, this one and this one, must be even. So on the other hand, b plus 4 minus c is smaller than b plus 4 plus c because c is positive. On the other hand, these quantities are both positive or both negative. All these remarks give us only two cases. Case 1, the two quantities are both positive. There is b plus 4 minus c equals 2 and b plus 4 plus c equals 10, because they must be both even, and this one is smaller than this one, and the only situation is this one. So this implies if we add these, we get b plus 4 equals 6. If we take the subtract these two equations, we get c equals 4. These imply that b equals 2 and c equals 4. Now we need to compute a. To do so, we must use this, the equation 1. So we have computed b. Then we can solve for a. There is we have a equals b. That is 2. B is 2 minus c. C is 4 divided by 2. C is equal to minus 1. Or a equals 2 plus 4 divided by 2, which is equal to 3. And the other case here is b plus 4 minus c equals minus 10, and b plus 4 plus c equals minus 2. Remember that this quantity is smaller than this one, and they must be both even, and their product is 20. Then the only situation is this one and this one. So this situation implies b plus c equals, if we sum these two equations, minus 6, and if we subtract, we get c equals 4. And this implies that b plus 4 equals 6. This implies that b equals minus 10 and c equals 4. This implies if we go to previous equation here, equation 1, this quadratic, we get A equals B minus 10 minus delta or C minus 4 divided by 2, or A equals minus 10 plus 4 divided by 2, and this one equals minus 7, this one equals minus 6, and over 2 is minus 3. So we have 4 situations of B equals 2. This situation will be. We take first case in grade 1. First case is A equals minus 1. And this implies, what is A? A is x plus y equals minus 1, because A is exactly x plus y, and B is x multiplied by y equals 2. There is x and y are solution to this quadratic. T square plus t minus plus 2 equals 0, and this quadratic has no solution in Z, and even in R it doesn't have a solution. We go to the second case where A equals this is case 1, A2. A equals 3, so this implies x plus y equals 3 and equals 2. Simplify equation, x and y are solution to this quadratic, minus 3t plus 2. And here we have equals 0 equals t minus 1 multiplied by t minus 2. This implies that x equals 1 and y equals 2, or vice versa, because the equation, our original diophantine equation has, so we have xy equals 1 2 or 2 1. We go to situation 2, which correspond to B equals minus 10. Here we have two cases, the case 3 and the case 4. Minus 10. And the subcase correspond to A equals minus 7. This implies that x plus y equals minus 7 and xy equals minus 10, and x and y are solution to t squared minus plus 7t minus 10. This equation has no solution in or new integer solution. So we go to the case 4, and in case 4 we have b equals minus 10 and a equals minus 3. So x plus y equals minus 3 and xy equals minus 10. So x and y are solution to x plus 3t plus or minus 10, because we have minus 10. And here we compute delta equals 9 plus 14 7 square. So we have two solutions. X equals minus 3 minus 7 divided by 2, and y equal minus 3 plus 7 divided by 2, then minus 5 here, 2. Then we have xy equals minus 5 2, or 2 minus 5, because these equations are symmetric in x and y. So the set solution is s equals minus 5 2 2 minus 5, and the first solution we have found first solution we have found 1 2 and 2 1. Pardon. One, 2 and 2 1. I've finished the proof of this problem. I hope you are satisfied with my solution. Thank you.